I don't write code backwards. I write my tests first and I do my design last. You do it the other way around? That's crazy. Let me show you why. Hello world, I'm Scott Bernstein. Creating great software starts long before we write a line of code with how we think about what we want to build. My first step when I write code is to separate out the what from the how. And this happens before I sit down in front of a computer. When we talk to our customers or our managers, executives, we talk in terms of the what. When we code, we think in terms of the how. How do we implement this piece? Versus what do we want to create? This keeps a separation of concerns and prevents us from polluting our abstractions with implementation details. This is the true essence of encapsulation. We are encapsulating implementation details so that we have the freedom to change them later without breaking a lot of other code. And this is how we achieve true agility in our software. And software agility is where it matters. So I have two phases of development that I dive into. First, I figure out the what. I call that analysis. And then I figure out the how. How am I going to build that? And I call that design. When I talk to my stakeholders, I think about and talk about the what we want to accomplish. When I work in actual coding on my own or with my team, we focus on the how we're going to implement this. I believe that this is critically important to separate out these two modalities of thought, because when we do, it gives a much better separation of concerns. And our code is far more modular, far more functionally independent, far more testable, less coupled. And that means that when we go back in to change it, there's less things tying it down. And so it's far more able to be changed, able to be updated. If you build simple software under 10,000 lines of code, then it probably doesn't matter much which methodology you use, because you can pretty much hold everything in your head. At least I could when I was younger. But that has changed now that I'm an old guy. And I really do need discipline to be able to keep me focused. When we build enterprise software, we have to impose more standards and practices because there's more things that could go wrong. Because I focus on the behavior that I want to create and the outcome that those behaviors generate, I build tests for those outcomes which support me when I refactor my code and change my implementations later. This is the secret to building highly scalable systems. It's not just about knowing the current technologies and frameworks. It's also about understanding the art and science of good design, of the language of design, how we build systems that are resilient and that have the ability to be changed, that have the ability to be extended in the future. This type of design allows us to change with the business needs, and it informs us on every level when we build software. I also want to point out that separating out the what from the how can be challenging for some people. Sometimes we describe what we want by describing how we get it. But when we separate these two perspectives in our code, it can yield a much more encapsulated system that's more straightforward to work with and change later. When I focus on what I want to build, I'm focusing on my goals and my constraints. I'm talking to my stakeholders to get a sense of what they want and why they want it, so that I can think about the better ways of doing what they want to accomplish. I often start with user stories. These are single sentences that state who the feature is for, what they want, and why they want it. And again, notice there's no room for how in a user story, because again, we want to focus on the outside in so that we can forge a strong interface. And this is critically important in software. The code that we build, the method signatures, the way we interact with that code has to be a tight contract, has to be well thought out and well defined so that we can keep a separation of concerns. I often start with user stories. These are these single sentences that state who, what, and why a feature is requested. I try to make these stories based on outcomes rather than the way those outcomes are achieved. I know it's common for non-technical people to tell developers how to implement a feature. And what they're trying to say is what the outcome is, but oftentimes people describe things in terms of how they want to get it. We as developers have to filter that because we want to understand what they want, but we also want to understand how to implement things in extensible ways. And that's the art of programming. That's the science of software development. And it's something that we got to be careful not to let our users tell us what to do because we're the experts, not them. We understand how to build software that's maintainable. And so, again, we want to listen for what they want, but we want to think about how to implement it ourselves. So we have to translate their requests into more generic statements. This gives me more flexibility when I actually implement. Now, this implies a lot. So what about all those other details that we need in order to write code? What about the database? What about the UI? And these are important things. There's architectural questions, which are the questions we need to know before we even start, like what platform are we using or what programming language are we going to code in? There are analysis questions, which are really about figuring out the what. And then there are design questions, which are figuring out how to implement. We need to figure out architectural questions before we actually write a line of code. And generally, we don't change these things throughout development. We're typically not going to change the platform that we're going to work on or the programming language that we're using midstream. How we actually solve problems and build models are details best left to coding, I believe, because we're in the moment and we can figure things out then more easily. Before I start coding, I consider what to build. First, I write some user stories. And for each story, I define acceptance criteria by asking the question, how will I know when I'm done implementing this feature? And I embody the answer into an acceptance test. And this could be informally by just jotting down what should happen when that feature is implemented. Or I could use an acceptance testing framework. I find it really valuable to have a really clear notion of understanding when I'm going to be done before I even start. And this helps me exit when I have enough behavior. And this is always a problem for developers. We tend to overbuild because we don't know when we actually have done enough a lot of times. We don't want to see our code fail in the field. And so we try to make it robust. But having acceptance criteria that passes when we are finished is incredibly helpful because it tells us, hey, you're done, and we can move on. And deal with other things. This keeps me from overbuilding and from wondering when I can move on. When my acceptance tests pass, then I can move on. I'll typically write stories and create acceptance tests for what I want to build first. And once I have a good sense of the stories that I want to implement, I'll start breaking them down into tasks. My tasks follow a different format than the story format. They follow typically the given, when, then syntax. Given some set of preconditions, when a trigger occurs, then some end state or set of post conditions will occur that I can validate against. And this helps me break down a big feature into a very more manageable task. I like my tasks to be something that I can do in half a day, 2 to 4 to 6 hours, something along those lines. And integrate and get into the build that fast. And I like to integrate code every single day if I can when I'm developing. When I write my stories, I'm defining my tasks fairly broadly. I'm mostly focused on the trigger and what the method signature needs to look like. This is the extent of the analysis that I do before coding. Once I have a user story and I think of it as a placeholder for more details to come later, then I dive into development. And notice I have not yet thought about implementation. I'm not thinking about the UI. I'm not thinking about the database. I'm not thinking about how I'm going to access the system. I'm only focused on what I want to accomplish, what the story is supposed to achieve, what I want the system to do. And once I understand the what I want to have happen, then and only then I focus on how I'm going to implement it. So I got my story. I got my idea of what I want to build. I got a good sense of that. And then I fire up my IDE. And the first thing I do after I set up my project is to write my first unit test. I do test-driven development. And so thinking about the interface to start has helped me a lot because that's the very first thing I need to do when I write my test. I want to write an assertion that calls the method that I want to implement, and it calls it with the correct method signature. So thinking about that method signature is important at this stage, okay? But even before I do that, I want to set up my test environment. And I do that, again, with the simplest approach I can take. So typically, the very first test that I write is a test that I throw away to prove that my unit test framework is set up correctly. So my test is simply assert true, and I pass in false. And that should put up the red bar because it should fail if everything is wired up correctly. And so I run that test. And if I see the red bar, I'm golden. I know that my test could fail if it needed to. And so I delete that and I start in to write my first simple test, my real test that I'm going to actually use. And I do that based upon the behavior that I want to create. When I'm writing my unit test, I'm focused on my method signature, what I want to use for my API, what parameters I need, and what I want my API to return. This is an essential step in forging a good interface for my API. And it happens all during the red bar phase of test-driven development while I'm writing my test, but not yet making it pass. At this point, I'm thinking about a lot of things. I'm thinking about how I want to call my API, what it's supposed to do, and what it's supposed to return, or what observable results it's supposed to create in the system that I can verify. I put all this information into my API call, and I call that API for my test. And I let the system then generate a stub for my API. My stub typically returns a default value, and I make my test check for a different value so I can see the test fail when I first run it. The red bar comes up, and I see, I got the red bar, and I celebrate because I've achieved so much. I understand what I want to do. I understand what my API is supposed to do. I understand the parameters it's supposed to pass in and what it's supposed to return back. I've gone pretty much halfway to finishing up my API, and I haven't even gotten the first line of code written, just the method signature. Okay, now I know what I want to build. I got the method signature. I know the return value, and I'm ready to start to code. I'm ready to start to dive into the how. Okay, now that I know what my APIs should do, what my parameters are, and what it should return, I can start focusing on how to implement this behavior. Now that I have a failing test and a dummy API call, I'm almost ready to start focusing on implementation detail. I just have one more thing to do, which is to make my failing test pass, because I only code and write production code in green bar when I have all my tests passing. So I'm going to, at this point, take the simplest possible implementation to turn that red bar into the green bar. And oftentimes that means dummy implementation. So if my test is 1 + 1, and I'm expecting the value 2 to be returned, and my test, my stub now returns 0, I just return it. I just force it to return the hard-coded value 2. And boom, I got the green bar. Of course, I'm going to change it later, but this serves my purpose for the moment, which is to bring me into green bar. And now I can start to think about how do I actually implement. In this case, it's addition, right? 1 + 1 is 2. That's easy to implement, but maybe it's something much more complex. And if it is, this is the time that I start thinking about real test cases. I think about a simple test case. I implement that. I think about maybe another more complicated test case if I don't understand it yet. And I write test cases until I fully understand the algorithm. And for me, that's usually 2 or sometimes 3 times. 3 test cases, usually I can triangulate a solution and understand. Okay, so I'm basically creating dummy implementations just to get to the green bar and see some possible test cases. When I see those test cases, that helps me understand how to come up with a real implementation. Okay, I'm designing how my API should behave. And once I understand its dependencies and I have a method signature, I can start really diving into implementation. I also have all my tests running, and this supports me because I'm in green bar, so it's safe. And if I make a mistake and change the end result of part of the API that I'm building, I'll get the red bar, and I can immediately back out that change. And that is incredibly valuable because I make these little mistakes many times throughout building my code. And if they were to escape, you know, and I didn't notice that, then oftentimes that would either be a problem in the field or, the testing organization would come back and I'd have to ramp back up and try to find that bug, and it could take a while. In the moment, I can fix it instantly. So it's really, really powerful. And it's one of the things that, you know, people who try test-driven development get really excited about. They see the value because if you can fix a bug in half a second versus half a week, it makes a big difference, especially when you got a pile of them. Yeah. So I have all my tests running. I'm in green bar. I have my method signature. I have maybe a couple of different example test cases, and those are what my tests are. My assertions are examples of what I want to build. And that helps me really get clear on what has to happen. And so I just work to get it green again. I work to get the red bar green. And that's how I implement. That's how I implement the how. I'll start with a simple implementation. And I learned this trick from Llewellyn Falco, one of my colleagues. I'll start after I write my test and I get my test failing. Then I think about what are the steps to make this test pass. And oftentimes I'll write that out in English as comments. So I'll comment out and say either step 1, step 2, step 3, etc. And I'll list that so I can see it there in front of me in the API. Here's all the steps. And then one by one, I'll go through each step and delete the comment and replace that comment with the actual code to make the step work. And I'll do that one by one until I get the entire API working. All my comments are gone, all my code is there, and it's running. All right. So then I look at the implementation and I say, okay, it works, fine. Do I have other tests that I need to also implement? And typically, once I get one or two more tests to implement, I'll see the pattern. I'll see the big picture. I'll discover the abstraction. And that will help me determine the design. Usually, I like to design with a couple of examples because those are real things that I can test my design against. So I start with a simple implementation. I write out my steps in English comments. And then I delete each comment as I implement each comment. And this leads to a very simple implementation that calls out each step. If I only need to do something once, I typically just code it up concretely. And when I need to do something similar a second or third time, that's when I consider applying a design pattern or using another technique to help improve code quality. I use the code quality that I'm working with as my test, as my indicator as to whether I need to change my design or not. When I need to do something similar a second or third time, I'll consider applying a design pattern or using another technique to improve code quality. And this is where I do the bulk of my design. When I already have a simple implementation, when I already have several unit tests running and green, because this is the safest time to code. All our tools are there and running and there to support us. If I don't have my tools, if I can't compile and I'm trying to write code, it's like I'm trying to code in the dark. It's like I'm coding with my monitor off or blindfolded. I need all my tools. I need my code to compile so that I can see if I make a mistake. And not just to compile, because the compiler can only tell me syntax errors. I need good unit tests that can tell me all the other kinds or most of the other kinds of errors. And good unit tests can if we write good tests. And this is the key. The key is to be able to write good unit tests, which very few people actually know how to do. One of my friends and hero, one of the most brilliant developers I know, Misko Havery, the author of Angular, and one of the most brilliant developers at Google, in my opinion, Misko says that he rarely meets a software developer who knows how to write a good test. Remember, he's at the highest echelons at Google, so he works with the most brilliant people on the planet, the top software developers there are. And he says that rarely can he find someone who knows how to write a good test. Now, we all know how to write tests, but what he's saying is a good test. And a good test is not just an arbitrary test, right? It's like a good statement, like a good line of code. It's not just wiggling your fingers, and it's not just being correct syntactically. It's about getting at the core of the issue. It's about testing the essence of the behavior, the essence of what it is that the business rule is, not the implementation of the business rule, not some side effect. And so really understanding that and being able to implement that gives a clarity of thought to the way we build software. I think that's one of the most important keys to building software. And again, it echoes this one practice that I keep talking about that is so important, which is separating out what, why, and for whom before how. The first practice that I talk about in my book, Beyond Legacy Code. And I made that the first practice because I feel it's like the core of everything, the core of coming up with a good design, which is to understand the difference between, the domain and the business rules of the domain model versus how we implement them. We don't typically make that separation, but that's a critical separation. And when we do, everything else gets better. Our code becomes clearer. We're able to extend our software. It's really that freaking simple. I got to tell you guys, and I didn't believe it for so many years. Al Shalloway, and who's going to be a guest on our show, taught me this. And I didn't believe it. So I tested it and tested it and tested it. And years later, I'm still testing it and it still works. So do it yourself, test it yourself. I was wise enough not to challenge Al, but just to say, okay, I'm going to try it. And I tried it myself and I learned. So try it yourself. If you doubt that these ideas work, just try it and see if it works for you. And I know that there's a lot of inertia in building software, in working with teams and dealing with management. But there is also an art and science to constructing software. And that's what I'm talking about. I can't help you with the other inertia, at least not at this moment, but I can help you with building cleaner code, and that can ripple out and make a big difference. This workflow is significantly better for me. It's much faster than any other approach that I've tried, and it's far safer, which is critically important to business. I end up producing better code faster. Who can argue with that? So what do you think? Want to give it a try for yourself? Would you like to see me demo these techniques on a project? Let me know in the comments. I have tons of related videos, so please check them out. There's a lot more to writing good software than just separating out concerns, and we're going to dive into them. So until next time, happy coding. Ciao.